So, good morning everyone. I am Añabesa, your instructor in today's session. So, for today's session, we're going to talk all about the comparison of rates in mathematics of investment course. So, there are three rates to compare. First, the simple interest rate and discount rate. The second, nominal rate and effective rate. Thirdly, the continuous nominal rate and effective rate. So first, let us talk about the simple interest rate and discount rate. The relationship between the interest rate R, or denoted by R, and the discount rate denoted by D is foundational in finance and economics, particularly in the context of present value calculations. The interest rate. This is the rate at which interest is paid by borrowers for the use of money that they borrow from a lender, given by the formula R is equals to D over 1 minus dt, where R is the effective rate, D is the discount rate, and T is the time. And this goes by days, months, or years. And always remember that in every rate, whether it is a simple interest rate, discount rate, or effective rate, or nominal rate, it should be converted to years. So if the given time or t is in days, so we just simply divide it by 360. We just simply use the Banker's rule. Or if it is in month, then we just simply divide it by 12. So to convert it annually. Then next, the discount rate. This is denoted by D. This is the rate used to convert future cash flows into their present value. It reflects the time value of money. Essentially, the inverse of compounding, given by the formula D is equals to R all over 1 plus RT, where D is the discount rate, R is the effective rate, and T is the time, or it goes by days, months, or even years. So this concept is very useful in finance world upon finding the equivalence of each rate. Knowing your present and future money is very important, as well as knowing the interest rate and discount rate of the money being invested. So to further understand, let's try to solve some examples or basic examples in real world applications. So for our example number 1, if the sum is due in 7 months, what is the interest rate equivalent to a discount rate at 8.5%? So to solve this, we just first identify what is the given. So we have here given the discount rate of 8.5%. So D is equals to 8.5%. Then our T or time is 7 months. So we have 7 over 12. And the unknown here is the interest rate. So we just simply use the formula for interest rate. R is equals to D over 1 minus dt to find the interest rate equivalent to a discount rate of 8.5%. So we just simply substitute the given values to the formula. So we have R is equals to 8 over 5%, which is RD, all over 1 minus 8.5% times the time, which is 7 over 12. That gives us 0.0894, or converted to percent, we have 8.94%. Therefore, the equivalent interest rate to a discount rate of 8.5% due in 7 months is 8.94%. So for our example number 2, to get 9% interest on a 90-day loan, what discount rate should a lender charge? So the unknown here is the discount rate, and we use the formula for discount rate. D is equals to R all over 1 plus RT. So to solve this problem, first we identify what is the given. So we have here interest rate 9%. So R is equals to 9%. And T is equals to 90 days. Since it is in days, then we just simply divide it by 360, which is the Bunker's rule to use the approximate time. So we have T is equals to 90 over 360. Then D is equals to R all over 1 plus RT, which is a formula in finding for our discount rate. Then we just simply substitute the given values. So D is equals to 9% over 1 plus 9% times the time, which is 90 over 360. Then we have now D is equals to 0.080, or converted to percent, then we have 8.80%. Therefore, the discount rate that a lender should charge to get a 9% interest rate on a 90-day loan is an 8.80% discount rate. And next, for our third problem, we have here what is the interest rate equivalent to a 10% discount in discounting amounts for 10 months. So same process, we just identify what is the unknown and what is the given. So the given here is D is equals to 10% and T is equals to 10. Then divided by 12, so we have T is equals to 10 over 12. And the unknown here is the interest rate, because that was the question was asking. So we just simply use the formula for R. Then we have D over 1 minus dt. Then simply substitute the given values to the formula. We have R is equals to 10% over 1 minus 10% times the time, which is 10 over 12. That gives us a result of 0.1091, or converted to percent, then we have 10.91%. Therefore, the equivalent interest rate to a 10% discount rate, that is discounting amount for 10 months, is 10.91%. And that's how you solve for the interest rate and the discount rate, to know their comparison, or how much interest rate that your money being invested have grown, or how much discount rate you get for that money. Understanding the discount rate and interest rate is essential for making informed financial decisions, protecting your investments, and ensuring that you get the maximum return of your money. They provide a clear picture of the value of money at different times, just like what I have said, which is the foundation of all financial and economic evaluation. So that's it for the simple interest rate and discount interest rate. Now let's talk to our second comparison, which is the nominal rate and effective rate. What is nominal rate? The nominal interest rate is the stated annual interest rate on a financial product, not accounting for the effects of compounding within the year. It is usually quoted on an annual basis. So this given by the formula J is equals to M times the quantity of 1 plus R raised to 1 over M minus 1, where J is the nominal rate, M is the conversion of rate, R is the effective rate. M there is on how many conversion happens within the year, or the money is being converted within the year, since this nominal and effective rate is in annual conversion. So next, what is effective interest rate? The effective interest rate, or the effective annual rate, takes into account the compounding periods during the year. It reflects the true cost of borrowing, or the true yield on an investment, considering the effects of compounding. So given by R is equals to the quantity of 1 plus J over M raised to M minus 1, where R is the effective rate, J is the nominal rate, and M usually the conversion of rate. So understanding both the nominal and effective interest rate is crucial for several reasons, especially when it comes to making informed financial decisions. So to further understand this kind of problems using the nominal and effective rate, we have here some examples to solve. So find the effective rate that is equivalent to our first condition when the nominal rate is 9% and M is equals to 4. And for our second condition, when the nominal rate is 12% and M, or the conversion of rate, is 2. So the unknown here is the effective rate. We need to find the equivalent effective rate of these given two nominal rates. So first things first, to solve this problem, we just identify the given. So we have here the first given, J is equals to 9% or the nominal rate, then M is 4 or the conversion of rates per year. Then our second condition, we have 12% nominal rate and M is equals to 2. So first, let's solve the first condition. So we have here for nominal rate 9%, nominal rate when M is 4. So we just simply use the formula for effective rate in finding its equivalent. So R is equals to the quantity of the quantity 1 plus J over M raised to M minus 1. So we just simply substitute the given values. So we have R is equals to the quantity of 1 plus 9% over 4 raised to 4, since M is equals to 4, minus 1. That gives us the result of 0.0931, or converted to percent, we have 9.31%. And for our next condition, when our J is equals to 12% nominal rate and our conversion is 2. So we have R is equals to the quantity of 1 plus our value of J, which is 12%, over the M, which is 2, raised to 2 minus 1. That gives us the result of 0.1236 or 12.36%. Therefore, the equivalent effective rate for a 9% nominal rate when M is 4 is 9.31% effective rate. And for 12% nominal rate when M is 2 is 12.36% effective rate. So for our example number 2, we need to find what is the better one, or which is better, the 9% nominal rate compounded quarterly or 8.8% compounded monthly. So to find which one is better, we need to use the formula for effective rate, since effective rate is the true result that your money could compound or could increase or growth within that compounding time. So you just simply follow. So we identify the given, which is J is equals to 9% and M is 4. Why 4? Because it is compounded quarterly, meaning it compounds 4 times a year. And for our second given, we have J is equals to 8.8% when M is 12, because it is compounded monthly. So we first solve for our first given when the nominal rate is 9% and M is 4 or compounded quarterly. So we have R is equals to the quantity of 1 plus J, which is 9% over 4 raised to 4 minus 1, which give us the result of 0.0931 or 9.31%. So now to find which is better, so we need to solve for the second given. So we have here when J is 8.8% nominal rate when M is 12, so we get 0.0916 or 9.16%. So as you can see, the better one is the highest effective rate. So the highest effective rate for this one is when the nominal rate is 9% and compounded quarterly, or M is 4. So therefore, the best nominal rate to invest is when the nominal rate is 9% compounded quarterly, since it deals a higher effective rate compared to other one. So it is better to invest when you are given 9% compounded quarterly. If you wishes to loan in a bank or borrow money, just like that, or to invest. So we have here example number 3, which is better, another one. So 10.32% effective rate when M is 4, or 10% effective rate when M is 2, or compounded by annual, or by annually, or every 6 months, just like that. So the unknown here is the nominal rate. We need to find the nominal rate. And so to solve this problem, we need to identify what is the given. We have here R is equals to 10.32% when M is 4, or it is compounded quarterly since it is 4, so compounded quarterly meaning 3 months every year. It is compounded 3 months every year. Then for our second given, we have R is equals to 10% and M is 2, or it is compounded every 6 months a year. So we have here the formula in finding our nominal rate. So we have J is equals to M times the quantity of 1 plus R raised to 1 over M minus 1. So we just simply substitute the given values for our first given when R is equals to 10.32% and M is 4. So we have J is equals to 4 times the quantity of 1 plus 10.32% raised to 1 over 4 minus 1. That gives us a result of 0.0994, or converted to percent, we have 9.94%. So we need to solve for the next one to identify which one is better. So J is equals to the value of Rm, which is 2 times the quantity of 1 plus the value of R, which is 10% raised to 1/2, or 1 over 2 minus 1, which give us the result of 0.0976, or 9.76%. So as you can see, the greater nominal rate here is when the effective rate is 10.32% when M is 4. So therefore, the better rate by using the nominal rate is when the effective rate is 10.32% when M is 4, since it has a higher nominal rate compared to other one. As you can see that it doesn't matter whether if the given rate is an effective rate, it does not matter how much the money is being compounded within the year. So understanding both nominal and effective interest rates allows you to first make better comparison between financial products, just like what we did. Then second, plan your finances more effectively. Third, understand the true cost and benefits of borrowing and investing. And thirdly, ensure compliance and transparency in financial dealings. So knowing these rates helps you make more informed, accurate, and beneficial financial decisions. So that's how we compare the nominal rate and effective rate if the compounding is given. So what if it is continuously compounding? So what do we do, or what formula do we use in finding the difference of each? So for our next topic or talk, then we now talk about the continuous nominal rate and effective rate. What is nominal interest rate? So the nominal interest rate or the continuous interest rate, this is the stated annual interest rate without taking into account the effect of compounding within the year. The nominal interest rate is the stated interest rate on a financial product, not accounting for the compounding within the year. It is usually expressed as an annual percentage. It is given by the formula J is equals to log of 1 plus R all over log of E, where J is the nominal rate compounded continuously and R is the given effective rate, or it is the given value in the question or the problem being given. So what is effective annual interest rate? This rate accounts for the effect of compounding over the period of 1 year. The effective interest rate takes compounding into account and shows the real return on an investment or the real cost of a loan. It reflects how often interest is applied and compounded. Given by the formula, R is equals to E raised to J minus 1, where E here is an exponential equation. It is a constant symbol, or just like a constant number, because E has a value just like pi, where R is the nominal rate compounded continuously and J is the effective rate. So to further understand, so let's solve some examples. Let's try to solve these problems. So our first problem, we have here condition A. Find the effective rate that is equivalent to a nominal rate of 9.5% converted continuously. And for our B, what is the force of interest corresponding to a 9% effective rate? What do you mean by force of interest? So this only means that the force of interest is equal to our nominal rate. So force of interest, because it is being affected. So if the given rate is compounded quarterly, annually, bi-monthly, monthly, or continuously. So for to solve our problem letter A, we need to find the equivalent effective rate of a nominal rate of 9.5% converted continuously. So first, we just identify the given. So we have here nominal rate of 9.5%. So we just simply use the formula R is equals to E raised to J minus 1 in finding the equivalent effective rate. So we have here R is equals to E raised to our nominal rate, which is 9.5% minus 1, which give us the result of 0.0997 or 9.97%. And for the solution of our letter B, problem letter B, so in finding the force of interest or our nominal rate, when we have an effective rate of 9%, so we have here given is equals to R, given is R is equals to 9%. Then the unknown here is the nominal rate, which is our force of interest. So we just simply use the formula for in finding the nominal rate. We have here J is equals to log of 1 plus R all over log of E. Then we just simply substitute the given values. Then we have log of 1 plus R, which is 9%, all over log of E. Then we get the 0.0862 or 8.62%. Therefore, the equivalent effective rate for a nominal rate of 9.5% compounded continuously is 9.97% effective rate. And the force of interest when having a 9% effective rate is 8.62%. So we have here another problem. So which is better? The unknown here is the nominal rate. We need to find the nominal rate when we have 11% effective rate or 11.5% compounded continuously. We need to find which is the better one, the 11% effective rate or 11.5 effective rate. And both are compounded continuously, meaning it grows continuously or indefinitely. So we need to find which one is better. So for our solution, we have here given R is equals to 11% and R is equals to 11.5%. And first, we try to solve for the first given where R is equals to 11% effective rate. So we just simply use the formula in finding our nominal rate, which is J is equals to log of 1 plus R all over log of E. Then we just simply substitute the given values where R is equals to 11%. Then we have J is equals to log of 1 plus 11% all over log of E. That gives us a result of 0.1044 or 10.44%. So to know which one is better, as always, we need to solve for the second given to compare which one has results to higher nominal rate. So we need to solve for the second one. So we have J is equals to log of 1 plus the second given, which is 11.5% effective rate. So we have log of 1 plus 11.5% all over log of E. That which results to 0.1086 or 10.86%. So as you can see, when the effective rate is 11.5%, it results to a higher nominal rate. Therefore, the better continuous rate is when the effective rate is 11.5%, which equals to 10.86%. So that is how to solve for the continuous nominal and effective interest rate. So understanding the difference between nominal and effective interest rate, particularly with continuous compounding, equips individuals and businesses with the knowledge to make better financial decisions, optimize their investments and loans, or manage risk effectively, and ensures compliance with financial regulations. So that is all for now. So I hope you guys have more or learned something, and thank you for watching this video. Have a great day. Thank you everyone. Bye.